Hello, welcome to today's FSEG webinar, Drilling Techniques to Maximize Exploration Success with Benedikt Steiner. My name is Deanne Ryder and I'm the Online Community Manager and the Webinar Coordinator for this series. I will first cover logistics for the webinar and a quick overview of FSEG before Benedikt will begin. If you have any problems with today's webinar or your screen freezes, just try to refresh your screen by pressing Control F5. If you have problems with the audio, you can call in through the phone numbers listed under the zoom.us Zoom conference. Just note that toll charges may apply, or you can check your join audio button and test the speaker and microphone. Today's call will be listen only for participants, but we encourage you to ask questions during the webinar by using the Q&A button in the control bar that should appear at the top or bottom of your screen, depending on your setup. Questions on the presentation will be answered during one of the 3 Q&A sessions throughout today's webinar. Today's webinar was part of a 4-part series targeting the needs of students and early career professionals. The webinar is being recorded and an archive will be available following the event. If you missed one of the previous webinars, you can access the archive on the FSEG website or on our YouTube channel. FSEG is a professional society devoted to the advancement, discovery, and responsible development of mineral resources. Our members are all over the globe and consist of both professional members and student chapters in various parts of the world. And with that, I would like to turn over the presentation to Benedikt Steiner. Benedikt?
Yeah, thank you, Deanne. Thank you very much, and welcome everyone to the 4th webinar in this series. Today we're going to look into drilling techniques. So whilst over the last few occasions we have looked into and discussed skills that economic geologists require to secure a job or to apply during their routine workflows, today's topic will really focus on what the important drilling techniques are in the mining sector. So I will first introduce the different drilling techniques that are commonly available to the mining geologist. And in the second part of the webinar, I will focus on specific issues that are usually encountered on drill sites. And that if you work on a drill site, I'm sure you will encounter at some point in time. Towards the end of the webinar, I will elaborate on the responsibilities of on-site geologists and explain what the common tasks are that geologists are undertaking on a day-to-day basis. So you might ask yourself, why is it important that we drill in the mining industry? Well, if you start from a viewpoint of geological mapping, the usual exercise that's been done at universities, or if you gather original data and have first field visits, you come up with a product that is available in 2D. Sometimes you're able to construct cross sections, and that gives you 2.5D or dimension view of the subsurface. However, in order to understand the dimensions of an ore body better, it is important that we acquire information in 3D. And the only way to do this is either to excavate the subsurface or indeed to drill. And of course, drilling is the more economic method of achieving this. Drilling is quite expensive depending on the techniques you choose. And therefore, it is very important that we geologists extract the maximum amount of information from the data that we obtain in drill holes. Drilling is very important because it delivers the information for future decision making, such as property evaluation, if you screen different properties for their mineral endowment, but also geotechnical issues, slope stability, and excavation factors, resource calculation, and mine planning. So after the original and the initial exploration has been done on a property, you will see that very quickly you will move into the drilling stage, which will then go all the way through to resource evaluation and planning. So what are the different applications or the types of drill holes that you can produce and that you can drill? Well, first of all, and the most obvious one is geological drill holes. And if you drill, for example, a diamond core, you will get information on lithologies, structures, grade, and that's what we geologists are usually familiar with. However, drilling can also serve to deliver information on grade control at mine sites and or blasting holes during the actual mining stage. You can drill holes to extract a certain commodity. That's, for example, oil, gas, water, or brines. But usually in hard rock mining, we are less concerned with this type of drilling. Very often mine sites, they also issue geotechnical projects, and that means that a certain part of a mine site is drilled just to gather enough geotechnical data to allow the engineers make predictions of slope stability and the excavation techniques that they are going to use. Drilling can also serve to dewater mine sites, whether it's an open pit or an underground mine, and drilling can be used for bulk sampling, and that's especially important in diamond exploration, as usually you have to sample quite a large sample in order to get your indicator minerals and or even diamonds. But before we dive right into the different drilling techniques, I would like to make you aware of a number of planning considerations that every geologist or manager needs to think through before embarking on a drilling campaign. First of all, you need to understand the actual aim of the drilling program. As a geologist, you need to ask yourself, what is the kind of rock that you're drilling? What is the depth and the shape of the ore body? Is it a narrow vein deposit, or are we talking about a large porphyry copper deposit that's been drilled? And that is related to the geometry and the architecture of the rocks. So are we drilling sedimentary layered rocks, or are we interested in very massive felsic rocks? You need to decide on the type of sample that you would like to obtain. So is it a diamond core that you would like to obtain, or is it just rock chips that you get from reverse circulation drilling? Very often, however, budget considerations are key in any exploration program. The mining industry is always strapped of cash, so that also has an impact on the technique you choose for drilling. As we will see later, the different techniques that I'm going to present, they have, they cost, they have different costs, and you should consider this. Staffing and logistics is also an important consideration in the planning phase, as usually companies would hire drilling contractors. Now that might be an easy enough task to do in a large mining hub or mining center. However, if you go to remote areas in Central Africa or Central America, you will struggle often to find appropriate drilling contractors that can deliver the service that you're after. Geologists should also be thinking about the actual material that's to be drilled, because that can have implications on the drilling techniques again. For example, are you drilling consolidated or unconsolidated overburden? For example, are you conducting soil drilling? And is that your main target, or are you interested in hard rock targets, or are you actually interested in a combination of all of the previous options? Now, these boxes need to be ticked before any of the tenders that are going out to drilling contractors, and it's a good way to familiarize yourself with what is required during a drilling program. That leads us to our first poll. Deanne, if you could bring up the first poll, please. And I would like to ask the audience whether you have used drilling techniques in the past and what specifically you've been predominantly using. So have you used reverse circulation drilling, diamond core drilling? Have you used sonic, a coiled tube rig, or an auger? So please indicate the techniques that you have used mainly in the past. All right, if you could pull up the results, Deanne, please. Okay, I think that's a very distinct answer here. We have 15% used reverse circulation drilling, 81% used diamond drilling, no one used sonic or coiled tube drilling, and just about 5% used auger drilling. And that is very interesting to see, because I would have expected more people to be using reverse circulation drilling on mine and exploration sites. So thank you very much for this first indication. And I think let's go through the drilling techniques that were just on that screen and discuss a bit more what they're all about. Move on to the first one, which is auger drilling. As you can see on the right-hand side, auger drilling principally is a first-pass drilling tool that's designed to collect unconsolidated samples from shallow overburden. What these gentlemen on the right-hand side are actually doing is for soil sampling, and usually with such a drilling technique, you can obtain samples that are a couple of meters deep, well, as long as that rod is in fact. And such a drilling technique can be used during conventional soil sampling campaigns. So instead of digging a hole, as we discussed during the last webinar, such an auger will help you to collect point samples. Now, the problem with the auger drilling is, even though it can be mechanized and it can be mounted on a drill rig, it's usually quite slow, and it can only be used in shallow overburden and soft material. As soon as you hit bedrock, or if you hit any boulders that are located within the soil, you will struggle and you won't be able to obtain a sample. And I think the image is quite self-explanatory. What geologists or samplers do is they drive this equipment into the ground and then rotate it around. And once the auger head is full, they pull it out and bag the sample into paper or plastic bags. So this is the easiest technique that is available on the market to obtain a sample. Sonic drilling is another quite specialized technique, and it is used to collect continuous unconsolidated samples from deeper overburden. It is usually employed in heavy mineral sands and glacial till exploration. And how it works is, as the name sonic suggests, you have, as you can see on the right-hand side, a device that's producing sinusoidal waves, and it's basically shaking the drill string further down, the drill pipe further down, and it leads to the drill bit rotating and vibrating. And using such a technique will allow you to drill through loose sands. And you can see that the final product is collected not in core trays or not in any plastic bags, but indeed in such plastic plastic hoses there. Sonic drilling is commonly used when the question is about obtaining a uncontaminated sample in soil. I've seen it being used particularly when it comes to glacial till exploration, when you want to obtain a continuous sample through a number of meters of till, and sampling at the bottom of that till package. Moving on from sonic drilling, the next actually quite recently developed technique is so-called coiled tubing rig. It is a project that has been developed by a number of Australian researchers over the last few years. And that's a really new development that employs a continuous reel of tubing instead of drill rods. And that obviously has quite a positive impact on economics and health and safety aspects. And I would like to elaborate a bit more on this. I've myself never used this type of drilling because it's quite new and it's under R&D at the moment. However, what I read from that website is that the drilling cost is only $50 a meter down to a depth of 500 meters. Now that is comparably a really cheap tool to obtain a sample, especially given that diamond drilling is usually around $200 a meter. That rig, as you can see on the left-hand side, is pretty small. It's less than 10,000 kilograms in weight, so it's pretty mobile and doesn't leave such an environmental footprint like the other types of rigs that we're going to see in a minute. You will have a minimal rod handling involved, and of course that makes it a lot safer to operate. So all in all, I wanted to make you aware of this latest development. Down there I've posted a link of where you can get more information about it. That research group has also produced a couple of YouTube videos that I encourage you to watch, as certainly such techniques and such developments in technology will certainly lead the way over the next few decades. Moving on to reverse circulation rigs. Those are, I think earlier on we said 11% of the audience has done some reverse circulation drilling. You will most probably recognize these graphs and these photos here. Reverse circulation drilling is generally a very fast and reliable tool. It's inexpensive and it's commonly used both in mineral exploration and mining stages of the mining value chain, especially during grade control drilling when quick holes need to be drilled. RC drilling is the tool of choice. And unlike any other of the techniques we have discussed so far, RC drilling produces not continuous pieces of rock or core. Instead, it produces chips, small pieces of broken rocks, and that can be used to identify minerals, lithologies, and can be used for chemical analysis. So what's happening during reverse circulation? Well, what you're having is, on the left-hand side, you've got in your drill rods, you've got a configuration of an inner and an outer tube. You will see that highly compressed air will be injected between the outer and the inner rod in this small space here, and this compressed air will then activate the drill hammer that's sitting at the bottom of the hole, and this drill hammer will crush the rock, produce these chips of broken rocks, and the sample will then be pushed through the inner tube and pushed up to the surface again, where geologists can sample it. And that should be seen on the next slide. So you can see the sample that's coming up from the drill hole is going through a number of hoses, and then through a cyclone, and then that's where an offsider or a geologist is collecting these cuttings. That is, again, one of the very common techniques employed in the mining industry. However, as with every technique, we've got a number of limitations, such as noise, dust. Usually out of that cyclone, you can see this pipe here on the right-hand side. You have, if it's a very dry sample, you usually get quite a lot of dust that's dispersed into the air. So it's not ideal if you drill near any settlements, because everything will be full of dust. RC drilling also has quite a limited depth. I myself have seen drill rigs drilling down to 350 meters in ideal conditions, but that really depends on the groundwater level situation. The technique will struggle very quickly if you have a high groundwater pressure, and that could lead to sample contamination, which I will discuss a bit later on. There's also a lot of space required for RC drilling, because you're not only having your drill rig, but you're having support vehicles, additional air compressors and boosters, and support trucks. So if you're operating in a forest, for example, you would have to clear quite a large space so that you can set up your drill rig and continue drilling. On the other hand, diamond core drilling, and I think that's the majority of the audience have been using this drilling technique before. It is what we as geologists commonly understand or commonly expect when we say, oh, we're embarking on a drilling campaign, as it produces this really useful core, which we can inspect and analyze and do all sorts of things with it. So diamond drilling is usually seen as a slow and an expensive techniques. However, that produces, of course, the most reliable and continuous record of drilled geological materials, unlike RC drilling, where we've seen that you get just a number of broken up rock chips. Drilling usually works by this drilling bit, which is rotated at quite a high speed, and the bit is cutting into the bedrock, and the rock that's being cut out, if you like, is being pushed into the inner tube, into the core barrel, and a wire line is then employed to remove that core or the core barrel and winch it up to the surface, where drilling contractors will then extract the core and make it available to the geologist. A number of particular specifications during diamond drilling that I would like to make you aware of are some additional options that you can employ. For example, triple tubing is commonly used when you drill through very challenging ground conditions. For example, overburden laterite or clays or fault zones. As you know, fault zones are characterized by sheared and destroyed rock. Now, if you drill through this through such a zone without any support, like triple tubing, which looks like two on the bottom photo, you can see that two detachable halves of metal tubing. If you drill without this triple tubing, you will encounter problems in core recovery. So it's usually encouraged to employ triple tubing when you know you're going to hit a problematic or challenging ground conditions. In diamond drilling, you can also use commonly wedges and deflection devices, and that's quite a specific application if you do directional drilling, but it's not unheard of to be used in the mining industry. And that will help you to deflect your drilling path into a specific orientation. You can also employ orientation tools during diamond drilling. And these orientation tools, such as the spear tool or the ACE tool, as they're known in industry, they help you to, or help the driller and the geologist to reconstruct the original orientation of the piece of core in the drill hole. And from that, geologists are able to determine structural parameters, such as the alpha and beta angles on fractures on joints, and from there calculate any other geological structures and phenomena. Good. I think we're arriving at our next poll, and I would like you to look into the following scenarios that Deanne can kindly put up. So we're trying to practice a bit the learnings that we just had. I'm giving you two scenarios, and I would like you to choose which drilling technique you think is the most appropriate. So the first scenario is a geotechnical and structural study of deep-seated nickel mineralization near Norilsk in Russia. I give you three drilling techniques. You can either drill reverse circulation, diamond core, or sonic. If you could choose the technique you think is most appropriate. And the second scenario is coal exploration in Australia. You are targeting quite a deep sitting coal seams at 200 to 400 meters. So what would you choose to explore for this kind of deposit? Would you use RC, diamond drilling, or sonic? Please make your choices, and then we can go through what your opinions are, and I can give you a type solution here. All right. If Deanne, if you could pull up the poll again and what people went for. Sound. Great. I think we have some very clear answers here. In the first scenario, geotechnical and structural study, no one went for reverse circulation and sonic. I'm disappointed. No, but it's good. You all sort of picked up on the importance of diamond core drilling. Of course, we have to use such a technique, not just because it's deep-seated, and our seam sonic drilling would never be able to go that deep, but also because we're interested in geotechnical and structural parameters. You would not get that from any sonic drill material or any RC chips. You would indeed have to drill core and then log the joint sets and fractures, and derive from that your Q factors or RMR, depending what you're using on the mine site. So that's correct. Well done, everyone. Diamond core drilling for the Russian example. Now the second one, coal exploration drilling, is indeed an interesting one. We have 72% of the audience voting for an RC drill rig, 17% only for diamond drilling, and 11% for sonic. Now, I think those voting for RC and diamond drilling, you're definitely right, but I think coal exploration is quite a specific undertaking. Now, both can of course be used for exploring this deposit, but if you really want to obtain an appropriate sample of the coal and then dispatch it off for your coal maturity analysis and volatiles and so on, you would have to ideally get a diamond core. However, reverse circulation can of course also be used, and even a combination of these two techniques is possible. So imagine you're drilling in a sedimentary basin, you're having 200 meters of sandstone, siltstones and shales as overburden. Eventually you're probably not going to be interested in what's lying above, unless you're reconstructing paleontology or you are interested in the geotechnical parameters. So in that case, what you can do is you can drill RC collar, as it's called. So you first drill RC, and then once you see you reach the coal seam, you would then switch the drilling device into diamond drilling and continue coring through the seam. So in this case, again, well done, everyone. Just remember that that is not necessarily a black and white choice, and you can combine the techniques. Thank you very much for that, for those insights. And let's move on. I have a feeling that we are approaching our first question and answer session. So let's take a look. There is one question, thank you very much, and it is, with regards to diamond drilling, is the water typically sourced on site? Good question, thank you. So that really depends on where you, of course, where you are drilling. I've drilled on many sites, and I can give you a couple of examples. So I used to spend a couple of years drilling in the Namib Desert, and as you can imagine, a desert, there's no surface water occurrence. So we investigated a couple of options to get the water, and of course one was to source the water elsewhere and then truck it in with a large water bowser, like a 10,000 liter truck. That is of course possible. On the other hand, you can use the water from existing drill holes and tap the groundwater. However, that needs often environmental permits, especially if you're in a desert, because you're tapping historic water, which is yeah, I wouldn't really favor this option. Elsewhere, I've drilled on mountain sites, and of course, on a mountain you won't find any water, so you have to use water pumps somewhere in the valley and pump the water up the mountain. So the answer to your question is yes and no. You can source the water on site or elsewhere. Do we have any other questions? There's one question. What are some techniques used for minimizing contamination in RC drilling? I will get back to this during the next part, where we can, where I demonstrate what actually you get in what contamination is very dominant in RC drilling. So I'm asking you to be patient for a little while, and I hope it answers the question itself. Great. So thank you very much for the answers, for the questions so far. Let us move on to the next part of the presentation. And this part will be concerned with considerations that you as a geologist need to think about when dealing with the different products that you get from sampling. And usually I lecture about this topic for a number of hours or days, so I'm just synthesizing the most important points here. A common question that is, or common problem that we face in drilling is, where do we actually take samples? Do we select samples across the entire ore body, or even the entire drill hole? Or do we do selective sampling, or in other words, just randomly pick samples where we can visually see mineralization? Now that's important because any such selective sampling will introduce bias. And why do I mention this? In times of limited budgets in the mining industry, people can be inclined to decide, yeah, let's only sample certain parts of the ore body, and we report these results and try and get more investment. Now, this is not the ideal way of doing it, and you shouldn't do the selective samples because, as I said, this will introduce bias, and it will also lead to erroneous resource calculations. So please avoid sampling only parts of the ore body. Okay. There's a way, or there are a number of ways to avoid sample loss and gain. And we will, in the next few slides, see a number of examples of core loss, of washout of the material during the core drilling, change in volume of RC chips, whether it's through dust blowouts or through incorrect sampling. And those are, in my opinion, some of the very important points you should remember when you're sitting on a drill site and observing the product that a drill rig is giving you. So RC chips sampling is usually done either on site, not so often in the lab. And remember what I said, RC drilling provides you with usually bags of crushed rock material. And in order to obtain a representative sample, because usually these samples are several kilos heavy, or even dozens of kilos heavy, you need to provide representative subsamples that you then later use to send off to the lab or use as duplicates. And one way of doing it is using a RIFFLE splitter. And that's a device, as you can see in images in figures A to C. And what's happening here is you insert, or you put the samples into the splitter, and it will, in an ideal case, produce two subsamples, and both should produce an equal amount of sample. You can see on the right-hand side that if you introduce your sample from a certain angle or direction, it will then produce not equal weights. And that is a problem if you trying to assess for the sampling technique or for precision, if you submit a duplicate sample later on. And that's how it looks in the field. That's a project in Africa where I've been involved with drilling through overburden into bedrock using RC drilling. In figure A, you will see that the big sample bags have been opened up and they are drying in the African heat. That's a quick way of removing the moisture, removing the moisture from the sample. You need to be careful as a geologist not to introduce any contamination. As you can see here, if you're not careful, you could have cross-contamination of samples. And when these samples are dry, you have your technicians or offsiders running the samples manually through a riffle splitter. And you can see on the bottom of figure B that there are two plastic sample bags that are collecting two subsamples. Okay. Importantly, if you use such a manual splitting technique, be aware that you have to clean that riffle splitter after each and every sample to avoid cross-contamination. And that can be done either by washing it out, but that means then that you have to wait until the device is dry again, or you just use a air pressure hose to quickly cleanse it out. Another type of splitting that's available is called cone splitting. And cone splitting is an automated splitter. You will have your sample coming from the sample hose through the cyclone into the cone. You can see on the left-hand side that cone splitting allows you to equally subsample the sample that's coming from above, from the cyclone. However, well, that can improve the sample representativity in collection, but it doesn't work when you hit groundwater table with a high water pressure. Now, usually RC drilling uses air pressures of up to 10,000 psi, and that usually removes and air dries the sample on the way up from the drill hole. However, if the groundwater pressure is so strong that the air cannot dry up the sample, you will get situations like in figure B, where you have just mud, falling through the cyclone or being channeled through the cyclone and then coming out of the cone splitter. And that not only contaminates your samples, it will also render the entire cyclone and the cone splitting useless. Now, I've had several occasions when this was the case, and either the problem was fixed by experienced drillers because they know how to use the different gauges in a drill rig, or if that was not possible, the only option to proceed is to stop RC drilling and continue with normal conventional diamond drilling. Perhaps some of you in the audience have had these issues before and know the problems I'm talking about. For those of you who haven't seen this yet, please keep it in mind that if you get such RC samples, they're as good as unusable, and you should reconsider the drilling techniques that you employ in your project. If things go well, however, and there's no strong water pressure, there are a couple of jobs that geologists are required to do on site. I'm saying geologists and geotechnicians. And I've posted a couple of figures here again. You can see in figure 1, we have a drilling technician who is getting and receiving the RC sample bags. They may be 4 to 5 kilograms heavy. The technician receives these samples from the drillers. He's currently logging these samples in a paper-based Excel sheet. Now that was, of course, something like 10 years ago, but that when his photo was taken. But nowadays there are much more fancy devices of logging samples on iPads or iPhones and smartphones. But there's no harm in collecting your data either straight into Excel or on a paper sheet. This technician also weighs the samples and makes sure that both the different subsamples that you get from the splitter have equal weights. Again, that's informing about the quality of splitting. And in this case, because it was a uranium project, the technician would also have used a spectrometer to determine the potassium, thorium, uranium content of each sample on the drill site. In figure B, you can see a geologist taking a subsample from these sample bags on the left-hand side. And the geologist is using a sieve to sieve in a water basin to remove the dust and collect those RC chips. And you can see that next to the green glove, he's got a plastic tray, which is illustrated in figure C. And you would normally then place the drill sample or representative part of the drill sample into these pre-labeled RC chip trays. And that represents a very good opportunity for the geologist to instantly observe the different lithologies that occur in each of these intervals. Another very interesting sample display technique that I've tried out is a so-called RC chips farm. And by the way, the inspiration for this I got from the book published by Marjorie Banks, that's an Australian geologist, in 2010. And I thought back in the day, why don't I just try what a tried and tested technique that people did previously? So I used a tarpaulin and then used a subsample of the RC drilling bag to basically create a virtual borehole. And you can clearly see that there are color differences in the from the top left to the end of the hole on the far right side. And that is a very useful tool for you to quickly understand what the geology is doing in your drill hole. And it's also very helpful for managers if they fly in from their base. You can quickly explain what the hole is doing, what the geology is that we're expecting, and if you see any mineralization. So I can really encourage you to use a similar technique on your drill site and help to improve the understanding of the geology that you're encountering. However, I mentioned earlier on the issues that you encounter on these drill sites. As a bit of a summary, we experienced wet sampling before, when you have a strong groundwater pressure and the compressed air cannot dry the sample. Again, there's an example of this in figure A. You can see it's not working, that RC drilling here. And you get a wet sample. The sump is filling up pretty quickly on the left-hand side, and it's not an ideal sample that we're getting. Now, interestingly, in figure B, you can see now that it's exactly the same drill site. 10 minutes later, you have suddenly a very dry sample, lots of dust. The drilling offsider is coated in dust and probably quite uncomfortable. So how did this happen? Well, let me give you the simple solution to that. The driller, so the person who's operating the drill rig, has been changed out, and the driller had a better understanding of how to use different gauges and so on the drill rig to remove the water, and probably he also injected more highly compressed air. So that, of course, means that depending on the skills of the driller, you will obtain better quality samples, right? But it's not always possible. And as I said, if you continuously get such wet samples, you better stop RC drilling and think about using diamond drilling. So we can see both in figure A and B, we've got sampling issues. In figure A, we've got wet sampling. In figure B, we've got a potential loss of volatile materials, or material that's going out through the dust. And so sample loss or volume loss associated with water and dust in both figures. And you probably will get, if you have especially wet sampling, unequal sample weights of the A and B sample. A very easy way to mitigate this problem is to use industrial scales on site. But you can also have sample contamination from wall rock. So think that rock from higher up in the drill hole is falling down the drill hole and is then crushed and sent up again. Clay stuck to the inner tube. That could all introduce internal and external contamination that you as a geologist need to be aware of. They all introduce also bias in the sampling technique in subsequent interpretation. So especially if you're on a resource evaluation project, this bias can become very critical. So your responsibility as a geologist on site will be to identify these problems, be aware of these problems, and then try to minimize the consequences of those. Great, so that leads us to our second question and answer session. Let's take a look. Here's a question. Which one is the more expensive drilling technique? Diamond drilling or RC drilling? And how much is the difference? Well, the prices usually depend on the location where you're drilling and the drilling contractor and the competitiveness in the drilling industry. But usually, if you use a ballpark number of $200 US for a meter of diamond drilling, and maybe about $50 to $60 if you're lucky for the RC drilling. So it's about $150 difference. You can clearly see that RC drilling is the most economic technique. However, as we've seen, there are issues and that you need to be aware of. Let's see if we have some other questions. How deep below the water table is it possible to get RC, dry RC samples using the booster? Again, this is a very site-specific question. I've drilled in places where the water table was about 20 meters shallow, and it was so strong that the booster was ineffective. I've had other places where I drilled down to 250 meters, and there was just, the sample was only a bit moist, so the air drying went well. So yeah, it's difficult to answer the question. It really depends on the site that you're using. So if you're drilling in a river valley, for example, where the groundwater table is high, then probably it's in the 50s to 100 meters perhaps. See if there's any other questions coming up. Can you discuss wedges? So what I can say about wedges, I think it was part of the earlier session. Wedges are usually metal plates. You need to imagine almost like that sized metal plates that are inserted into the drill hole and then orientated along a certain angle or orientation, and it needs to be done by a very experienced person. So as soon as you have such a metal wedge in the drill hole, your drill string will automatically be deflected into a certain orientation and then follow a deviated drill path. Right? So that's called active deviation of drill holes. Excellent. So thank you very much again for the questions you asked. We still have a few slides to go, so let me kindly move on, and it should lead us to diamond drilling sampling. Again, I could lecture perhaps a few hours or days about it, but the key important messages here, I'm running through a number of slides. An important objective of drilling management and sample management is to keep a record of the material you drill for future reference and for archives. And for diamond drilling, there's no better way of photographing your core boxes. Now, people usually do this, but I've also been on sites where this doesn't happen. And it's on these sites, I usually recommended people to quickly implement such processes. And why is it important to take a photo of your core box? Well, in these examples that you can see on the slides, this is fresh, pristine core, and it hasn't been touched at all. It hasn't been muddled with, and it's important to capture the information on it before a geologist or any other person starts to mess with the core, and that can happen very quickly. For example, when people start marking samples on the core, or start doing the meter marking, or try and cut the core for sampling, or people just inspecting the core and then putting it back into the wrong into the wrong compartment of the drill core box. So believe me, confusion can come up very quickly if you leave core boxes with geologists. So take a photo, indicate the most important information on that drill rig, on that drill hole, and then archive it on your server or database. And such an archiving really works wonders. I had several occasions in the past where I had to go back to the drill photograph archive in order to figure out a number of problems that we identified later on in the drilling. Such, for example, artificial breaks. Artificial breaks are introduced when people start hammering the rock. That can be both geologists and drillers. And of course, if you do a geotechnical investigation, you need to assess how many open or closed joints and fractures do you have. Now, if these artificial breaks that are introduced after the the drilling process has finished, if they're not marked correctly, you might get erroneous results during geotechnical aspects of the drilling. So keep this in mind. Another important, very important aspect is the use of core sampling using a diamond saw. These photos here are self-explanatory, but I would like to highlight a number of aspects. The first aspect is that, of course, if you cut a core into two pieces, you usually do this along a predefined cut line. You can see on the bottom left that core has a cut line indicated on the top part of the core. Now this cut line should not coincide with the so-called orientation line that you get when using orientation tools such as the spear tool or the ACE tool and others. For the reason that you will destroy the orientation line, and later on, give it a few months later, you will struggle to identify which core had orientation on it and which core didn't. Okay, so if you use orientation lines on a course, please make sure they're somehow 15 degrees offset from the cut line. The next important aspect that most of us deal with, especially if you're working in narrow vein mineral deposits, such as orogenic gold or any sort of tin and tungsten deposits, is what happens if you sample the two halves of your core. Now, it's very interesting. So you can see on the right-hand side that one half of the core is being bagged and sent off to the lab for analysis, and the other one is returned to the core tray as archive material for geologists to log and do further analysis on. Now that is the theoretical case. However, often you have to consider, first of all, nugget effects of very nuggety mineralization. So if you could insert one half of the drill core and that contains the mineralization, whilst the other half, which is in the archive material, does not contain any mineralization and therefore is blank. Okay, so that means that if this situation is reversed, you will, so no grade in the sample bag, but grade in the core tray, it will mean that your assays will return no grade of gold, for example. And there's been lots of research and work going into it. I encourage you to read up on some of these papers because this is a highly important problem, and people have suggested a number of solutions for this, such as using the entire drill core for analysis, but that means, of course, that none of the drill core is left for archiving and for other logging. Okay, there's no easy solution to get around this. However, if possible, I'm personally trying to use what's called quarter core. So if you cut your core into two, and then again, one of the halves you cut into two again, so you have 2 quarters there, and you use those for duplicates and for the original sample, that should hopefully minimize this effect. However, it needs geological observation and the input of a geologist where to put the cut line and to minimize such nugget effects. So in summary, to wrap this up, there are a number of issues in diamond sampling, such as what we just said, half versus quarter core, when it's used for quality control. Orientation lines should not be coinciding with a cutting line. You should always be concerned about the amount of sample that you want to retain for your duplicates or for your archive. And be aware that different sampling methods obtain different types and volumes of sample. This is now perhaps taking into account this a combination of drilling, like we talked about earlier in the coal exploration case, where you have we start RC drilling, and then you stop and continue with a diamond core. Now, of course, this introduces different types of samples, different volumes, and in reserve and resource calculations, that has a major impact. A few other issues that are commonly identified is that there could be errors in the location of samples. So if you don't desurvey your holes, if it's an angled hole and you don't obtain the XYZ coordinates through the use of gyroscopes or single or multi-shots, that could lead to erroneous interpretations. And what I've also observed is that bulk density determinations are often neglected, and that is truly important to be aware of this fact, because for every tonnage calculation, you need to, of course, know the bulk density of the rock that you intend to mine or move away or strip away. Okay, so there's again a common question: how often do you take bulk density samples? So I'd rather encourage you, if you're in early stage projects, to take more density samples than less. It's very easy to measure specific gravity, and if you train up a technician to get this job done, then you can reliably report density measurements of drill core to resource geologists. So I think we're running out of time, but I just wanted to sum up the role of the on-site geologist in the mining industry. And first of all, is what I experience to be the most important factor is in-country capacity building and training. I might have mentioned this during the first webinar that we had a few months ago. Once you're on a drill site, you are responsible for what's going on there. Now, it's not just health and safety or the technical matters. You are running that show, and you're expected to be competently managing a drill site. That requires that you need to train up field assistants or junior geologists or people who are new to the site in a number of aspects, such as the ones we've talked about in this webinar. As a geologist, you need to decide on the correct drilling method, and that's why we had earlier in the webinar had a look into the different techniques. We had a poll, and I was very happy to see that we had very good responses on deciding what is the correct drilling method. It sounds like an easy task, but just be aware that this needs to be looked into. Often geologists are involved in understanding or negotiating and executing a drilling contract, and you will be liaising with procurement people in the office. Project and time management, looking after budget is another key point that you need to follow, need to consider. Usually you start off as a rig geologist. After a few years, perhaps you will be given responsibility of leading a drilling program, and that is quite a task. So usually during the first years, you get trained up, learn everything about drilling and the techniques before managing projects. And importantly, as I said earlier, it's essential that you identify arising problems on drill sites. We discussed some of these problems, and I encourage you to take note of these and implement or recognize such situations in your daily work. It's of course also important to ensure the data quality, the correct sampling techniques, and quality control. In terms of quality control, we had a short session about this during the last webinar. If you were not able to take part, it should be on YouTube, and you can recap on quality control. And of course, geologists are involved with all the technical aspects of logging, database management, modeling, and putting this into a format that mining engineers can use. So our last question, Q&A session. Let's see if new questions have come up. Let me quickly see if there's a question. When is the best time to take a picture of or photo of the core? Before the meterage markings or after the meterage markings? Well, first of all, what I forgot to mention earlier is that ideally you take the photo in a wet state, so you make the core wet, because then you can see the geology a lot better. But I've seen, in response to your question, I've seen people doing it differently, some taking photos without the meter markings, some did put the meter markings on. I think the meter marking will not too much affect the consistency of the rock, and probably will not affect the geologists messing with the rock. So as I said, I've seen both. You can either do it before or after taking the meter markings. Excellent. Okay. Great. I've got a few more slides here, but that brings us basically to the end of the webinar. I quickly sum this all up. During this webinar, we've learned about the different drilling techniques, about some of the specifics like auger drilling or coiled tube drilling. I haven't talked about that too much, but I focused on reverse circulation and diamond drilling, because those are the ones that have been for a long time and are currently the main drilling techniques in use. I mentioned the importance of ensuring quality of the drilling process and workflows, and we talked about the responsibilities of rig geologists who have to deal with frequent issues such as wet RC samples. All right, that brings us to the end of the webinar. We have another poll available, and as this was the last webinar in this series, there are currently not any further webinars planned from our side. However, we would like to get your opinion on a number of topics that I could present about in the new year, in 2020. And that's covering, examples like exploration logistics and procurement, pragmatic approach to health and safety, digest and analytical techniques in geochemistry, or for example, using assay data in exploration and mining. Those are just some examples that I had, or some ideas that I had that I could talk about. But please give us your opinion on this, and we can then internally discuss it further. So if Deanne, if you could put up the poll, just select the ones that the one that you are most interested in. And Deanne, let's see what people have chosen, what the results are. Okay, interesting. Thank you very much. So about 14% are interested in logistics. No one seems to be interested in health and safety. Very interesting. But I need to remind you that health and safety is key in the mining industry, especially on mine sites. People are interested in digest and analytical techniques, but also interested in interpreting geochemical assays. I think that's what people are most interested about. So, yep, thank you very much for this indication. We will take this forward and discuss internally how we can, or if there's a possibility to arrange it in the new year. Just one more slide here. I'm posting a few references. A few comments during the last webinar indicated that it would be helpful to have references. So when this webinar comes online, please feel free to check these out on YouTube. And I would like you to make you aware of a number of initiatives that I've been planning together with the FSEG. Just a few training events that are coming up where the skills that we talked about have will be discussed in more detail. I'm going to run the exploration boot camp again, this time in Finland. It will consist of 2 parts. In one part, we will talk about how to target orogenic gold deposits using geophysics and geochemistry, and an exciting part in the field where we will go to the Arctic Circle and start looking into gold deposits there. So that's the boot camp, the FSEG boot camp that we have planned. And for those of you who are interested in another short course, we are hosting a practical exploration methods workshop in Colorado at the FSEG headquarters. Both of these events can be looked up on the FSEG website. If you're interested, please take a look. Again, those are covering some of the essential exploration techniques that geologists commonly employ in the mining industry. All right, thank you very much for your patience and for your interest in participating in these webinars. I hope this was all useful to you and you could take something away from it, improve your work or prepare for job applications, get some additional knowledge. I hope that has furthered your understanding of mining and of economic geology. And yeah, so I wish you a good remaining day, and I hope to see you around maybe another time. Good, I hand over to Deanne. Thank you very much.
Thanks, Benedikt. And for everyone joining us today, once you leave today's webinar, you will see a survey, and we ask that you complete that. Your input will help us designing future webinars. And as a reminder, Benedikt mentioned this just a bit ago, that an archive of today's presentation will be available on the FSEG website as well as the FSEG YouTube channel. So check back to either of those to see the archive. Thank you for attending today's webinar.